So, in the NDT method, magnetic particle testing, yesterday we talking about magnetic particle testing is doing on ferromagnetic material to detect surface and near surface discontinuities. So, one of the major limitation we observed there is magnetic particle testing we can use it only on ferromagnetic material. The other material it is not possible because we cannot magnetize. So, to overcome this problem, because we know industry we have so many other materials like stainless steel, aluminum, glass, plastic, so many other materials we have which we cannot magnetize. So, to overcome this problem, one of the another NDT method we are using to find the surface discontinuity, that is penetrant testing, liquid penetrant testing. So, liquid penetrant testing is an NDT method we can use on all material except porous material. You know which is the porous? Porous means some material there is some absorbing nature, like a sponge, our skin, wood, like that, which is there is absorbing character. Such material we cannot use. So, all other material, even ferrous or non-ferrous or magnetic or non-magnetic, any material we can apply penetrant testing. No, wood is a porous type. So, to detect the surface discontinuities which is open to surface, that is another problem of this penetrant testing. Magnetic particle testing, if there is any defect, even it is close in the surface, then also we can find out. But the penetrant testing, it is not possible. Penetrant testing, the defect we can detect only which is open to surface. If there is any 1 mm or 2 mm depth, if there is some defects, but it is closed on surface, it is not possible with the penetrant testing. So, whatever the defects on the surface, it should be open to surface. Then only penetrant can enter into the defect. So, penetrant testing is a method we can detect the surface discontinuities which is open to surface. Such a material, such a defects we can find out with the penetrant testing. So, always any defects, but if there is any cracks or something, it should be open to surface. So, that is the method we are using for the liquid penetrant testing, and it is a very economical, very easy, not too much critical procedure like that, and not too much skill required. So, it is one of the economical method we are using to find out the surface discontinuities. So, here we will explain some basic theory about this penetrant testing, and we will familiar with the chemicals which we are using for the penetrant testing, and we will perform some penetrant test on our artificial defects test pieces. Just for the information, there is some history of the PT, because very olden days it is using for the railroad industries. It is called oil and whitening method, because that time not penetrant that time. So, what they are using is in railroad and big plates, the oil which they are using, the oil, they are pouring the oil on the plate, and the oil will enter. If there is any discontinuities, any open surface, the oil will enter into that discontinuity. After some time they will wipe out the oil and put some chalk powder, white powder on that, and if there is any defects, any leakage, the oil will flow out. So, this method, this is the olden method we are used in olden days. After that gradually they started to use the color dyes, fluorescent dyes, water washable, solvent removable, like that. So many advances are almost 1960s only the water washable types and all these are coming. So, this is the old history of the penetrant testing. The purpose of PT is to detect the discontinuities open to the surface in solid non-absorbent materials. That is what I said. Non-absorbent means non-porous material. It should not be porous. So any discontinuity we can detect, it should be that point is very important, that should be open to surface in non-absorbent material. After that we can identify through evaluation those discontinuities that do not meet the code or specifications, and we will make a report. That's a simple procedure only we have to do PT. And some basic principles of this PT is, the first one is the capillary action. The basic principles, the penetrant testing is going on with the basic principle of capillary action. What is the capillary action means? Any liquid, there is a tendency to enter into the defect in the openings. It can enter or it can climb. So that tendency is called capillary action. So such a capillary action, such a capability, it has the penetrant materials. And there should be some wetting characteristics like a contact angle. Whenever, because all these are not related to our this one, because already the manufacturer doing all this, and as per this order only they prepare the penetrant material. So this contact angle should be always less than 90 degree. The angle should be less, there should be easy wettability. The wettability will increase. And it's like a surface tension, dye concentrate, viscosity, and contrast ratio. These are the basic principles we are following. So we can go one by one. Yeah. For this penetrant, this is the characteristics of this penetrant. The penetrant we are using, this is the characteristics, or these are the principles we are following for this penetrant. Yes. It's not clear. Okay, this is a two glasses like this folded together, and if there is any opening, if we apply penetrant on here, what will happen? The penetrant will enter into the openings. If there is any opening, any small opening in between two materials, the penetrant will enter. That action we are saying capillary action. Capillary action of the penetrant. So this is the capillary action. The tendency of a liquid to climb when exposed to small opening. So the basic principle of penetrant testing is capillary action. Like oil rising on wick, these are just examples. Sap rising on a tree, water soaking into the towel, or ink absorbing the chalk pieces. So many examples for the capillary actions. The second one we are talking about contact angle. When a liquid pour into the surface, the contact angle with the surface should be as low as possible, because if it is less than 90 degree, there is a good wetting. So because whenever we apply penetrant to the surface, there should be a good wettability. So the surface angle should be less than 90 degree. It will provide us the good wetting ability. Yeah. Yes. If it is less than 90, 60 is okay. Good. Yeah.
The very first figure. This is 120, yeah, angle.
Yeah.
But the same figure from the other side is 60.
You mean the opposite side?
Yeah.
No.
How we are going to calculate here? Yeah, you got that one? From here is 60, yeah?
Yes.
And here is also 60.
Yeah. No, but on the pouring side, we are talking about the pouring. But if you have some liquid is pouring into the plate.
This is it means this is the tip distance from this.
Yes. Yes. So the pouring, during the pouring time, that angle we are just calculating. So less than 90.
Pouring, how is it possible 120?
But
This is my point.
yeah.
This is 90. Yeah?
Yes.
Here is 60.
Yes.
Same. But from here, this is 120. Same.
Yeah.
60 from the other side. But it is same.
But when the flow, because they are asking about the flow of the penetrant.
From here, the flow will be this side.
Yes,
Same.
yes.
But from here, flow will be the other side. This is the same. What will your factor will be here?
But only one side it is flow. If you are spraying, so each liquid, each point, the spraying will go to the other side only, forward only. So the wetting ability, the flowing, it will go on the forward direction, right? Yeah. So that angle only they are calculating.
But if there is value being here, let's go here. And I am trying here, it will bend all the feet.
Yes.
Same if I find it here. Yes, it will be the same. I
Try
think.
to do it as a 60 degree.
Yeah.
Take this drive, okay, and do it at front of us.
Yeah.
Do
No. Like
like
this.
this.
This is. I am trying from penetrant here.
Yes.
This is 60.
Yes.
And if
I
I do
do it
from
here,
this,
from
from
here.
this is
No,
also 60.
This is not the spray angle it is telling.
Yeah, but
It is telling about the liquid on the plate surface, not the spray angle. No,
okay. Leave it.
yeah.
Then how it is in practical use?
No,
120.
not possible. Because that is the characteristic of this penetrant only. Because in the practical sense, it is not possible as.
Yeah, that's why I'm
Yeah,
saying that this is the same actually.
Yes,
It
we are
should
not talking about the angle.
Can you do it in
Yeah.
No,
Actually, there should be written that it should be less than 90.
less than 90 degree, enough. Because that is the characteristic of this penetrant
Yes.
liquid. We cannot measure here.
Yeah.
Okay.
This is not our
No.
flow rate.
No.
Traction.
No.
It is just a penetrant,
Manufacturers
absorption or capillary.
capable, yes. So the next characteristics given for this penetrant is they are saying the surface tension. Surface tension, like that, it's a phenomena of a surface liquid caused by intermolecular forces. All these things, these characteristics, we cannot measure on our penetrant or on our practical experience. The manufacturer in their lab, all these parameters they are followed to prepare one penetrant chemicals. That's what. Just for the principles we are talking about that. The other one is the viscosity characteristic. What is viscosity? It is resistance to flow. Resistance to flow. Suppose water and we are flowing some water and flowing some honey. Yeah. So the water will go speed and honey will less. So we can say honey is more viscous than water. So the penetrant should have such a capability. There is some viscosity, one of the characteristics of this penetrant. And another one, last one we are talking about, there is one contrast ratio. So each penetrant there should be some contrast, like black and white. Yesterday we, to get the contrast in magnetic particle, we do some paint, white paint, then apply black ink. So the white to black contrast is very good, because the white has, it will reflect all incident light, visibility. And black just opposite, black will absorb all light. So in this case, we are using the penetrant that is white. We have three chemicals here for the penetrant testing: remover, dipenetrant, developer. Three chemicals we are using. So this developer is always white in color. It's a white powder. White. Good morning. So the good contrast. To get the good contrast, what we will do? We have to use black. But unfortunately, no manufacturer manufacturing black dipenetrant. Somehow, some reason or somehow they are not manufacturing. They are manufacturing only pink or red type. So in this situation, the contrast ratio with white to pink, it's almost giving us more than 10 contrast ratio. So below 6 is very difficult. So above 6 is okay. So almost 10 contrast ratio we are getting with this white to pink or red. So this is the contrast ratio of this penetrant. Because the 10 means I am saying if there is a white background, white will reflect 100%. Okay, we can say 97% it will reflect. And this red penetrant, there is a reflection power of around 10%. So almost 97 divided by 10, 9.7 to 10. So this is the contrast ratio we are getting to the penetrant material. If it is black, we will get a good. White to black, we will get a good contrast, but we have no black penetrant. Yeah, penetrant is coming only this color in the visible and otherwise fluorescent. That yellow, green color we are coming. So mostly the dye penetrant color is maybe because of industry, industry everywhere black color, so to immediate notice red is good. If there is any defect or anything, it's easy to identify. So maybe that's why the reason they are using the dye color, dye penetrant, red type penetrants. Sir, we are talking about the penetrant just a surface. The basic theory is penetrant testing we can use only on non-porous material, which is open to surface. So that is the basic, and these are some basic characteristics of this our penetrant. It is worked on the basic principle of capillary action. Capillary action means a liquid can enter into an opening or climb into the opening, and it should have some viscosity, some resistance to flow. It cannot flow like water, and there should be some contact angle, and there should be some contrast ratio of this penetrant. So depends on this penetrant nature, we are working through this penetrant testing process. So these are the basic procedure while doing PT. The first one is prerequisite and surface preparation. So instead for doing the penetrant testing, surface preparation is very important, because already we told there is one of the limitation of penetrant testing is the defect should be open to surface, then only we can detect it. So when we are preparing the surface preparation, we should take care of that, because some surface preparation is not allowed in penetrant testing, like power brushing and sand blasting, grit blasting, because maybe there is a chance of smear these discontinuities. By sand blasting, maybe small crack opening, maybe a chance to smear, cover these openings. So like power brushing may be the powder from the power brushing, maybe it may enter into that small crack opening, it will close. So maybe it's very difficult to get in the penetrant test. So whenever we are preparing the surface preparation, this sand blasting, power brushing, like that, some methods they are prohibited and they are not allowed to do the surface preparation. The second, we will do surface cleaning. Whenever the job is ready, is in as welded condition or whatever it is, when the job is ready, we will do surface cleaning with our solvent. Or any method we can use for surface cleaning. We can use a detergent, we can use a solvent, surface etching, or some ultrasonic methods, vapor degreasing. So many methods in industry they are using for surface cleaning. Purpose is clean to the surface from the oil or any foreign material on the surface of the material. So before doing PT, the surface should be very clean. Next step, we are going application of penetrant. So first the job is ready, second is the surface is clean and it's ready for the job. After that, we will apply penetrant on that job. So the application may be any way. We can spray, or we can use a small brush, or we can pour, or we can dip. Any method we can use. There is no any restriction. Only thing is the surface should be covered by the penetrant. So you can use any method. There is no problem at all. After the application of penetrant, that is very important, we are waiting for the dwell time. Dwell time means it is the time the penetrant remaining on the material surface. How much time the penetrant will be there? We apply penetrant and we are waiting, because the penetrant has to give some time to enter these defects. So this time is very important and it is called dwell time because different manufacturer giving different time. Maybe in our penetrant bottle they written. This should be our, most of the penetrant they are written in 10 minutes. 10 minutes. But some procedure, they are saying we need 20 minutes, we need 50 minutes. And some manufacturers saying we need 240 minutes, some chemical there is a 240 minutes after applying because to find out some stress corrosion cracks, some minute cracks. Maybe by experience, they experiment that, this much time they required. So either we should follow manufacturer recommendation or our procedure. What we are telling about dwell time, because procedure usually we are making as per our experience. We experienced from our project, okay, this much time is required for our defects. So we can follow the procedure, or on the bottle the manufacturer is saying this is the dwell time. So minimum usually on common practice is 10 minutes we are giving. So 10 minutes. So after this dwell time, what we will do? We will remove the penetrant. We will wipe out from the surface, not into the defects, whatever the excess penetrant on the surface of the material. We will remove with a lint-free cotton cloths and clean with a solvent. After that, we will apply the developer. Developer is just for the contrast, back contrast. We have the developer, it's a white in color, and apply developer evenly. Same developer also we will give some time for the wetting. Usually 5 to 7 minutes we are giving for the developer to wet equally. Then we will start the interpretation and evaluation. So what is the difference in interpretation and evaluation? Any idea? The step is?
Whatever you are watching,
Yes.
interpreting in different, based on your experience or based on your standard.
Exactly.
Evaluation means once you are going for any identifying this, whether this is defect or this is.
Exactly. Exactly, you are right. Yes. Interpretation means just we are saying, oh, this is a crack, this is porosity, oh, this is a defect. Discontinuity. We are not saying defect, this is a discontinuity. But through evaluation, we are finalizing. Oh, as per this standard, this is rejected, this is accepted. So we are doing interpretation and evaluation, and finally we will do post cleaning, because penetrant testing, it is very important final cleaning, because this material will be go for further processing. It's already a chemicals, and maybe this interaction with some other chemicals may be a damage to our material, future corrosion or something. So last, post cleaning. So this is the simple steps we have to do.
About the pre-request,
Yeah.
self-preparation.
Yes.
If I have some bar, I weld it.
Yeah.
I weld it directly, I mix the test. First make cleaning for the surface or machining, and after that you need cleaning.
Yes, after that we have to cleaning. Because surface preparation doing, because most of the, suppose a weld surface preparation, what they are doing? They are doing some grinding or wire brushing. It is as welded condition. Now this is a test piece. Now this is a test piece. This after welding, what they are doing? They are doing some wire brushing or some cleaning only. But still it's as welded condition. So there is, this is the surface preparation. But in this case, what they are doing, after welding, they will again clean more. So you cannot see the weld ripples. So it's more cleaning they done. So whatever the condition the product is getting for the testing, that is the prerequisite. So in this case, we are saying do not do sandblasting. Because if there is a minor, yesterday we saw one minor cracks is there. So maybe do sandblasting, there is a chance to close that. Maybe sand will enter or it will smear the openings. So after applying penetrant, maybe there is a chance to block or we cannot detect the discontinuity. So after the prerequisite, we have to do again surface cleaning to remove any oily or. Yes. Yeah, but most of the site they are doing grinding, power brushing, everything they are doing. Yes, but usually in the welded condition they are only actually doing only manual power brushing. Usual welding conditions. They are not going to do again grinding. So only the manual power brush, wire brushing. Yeah, they are doing. And some more prerequisite we have. As yesterday, as like MBA, we need some lighting. Yesterday we talking about the lighting intensity, the white light. If it is in a closed area, at least we need 100 foot candles. Minimum 100 foot candles. If it is outside, if there is no controlled light, we need 35 foot candles. Or like this workshop area, closed area, we need 100 foot candles to see the indication. Next one is a temperature. Yesterday we talking about magnetic particle. I think we didn't mention the temperature. Actually, the magnetic particle, wet magnetic particle, we can do up to 57 degrees Celsius. 57 degrees Celsius temperature, we can do the wet magnetic particle testing.
Body temperature.
Yes, object temperature.
Sometimes in the kingdom we are doing normal temperature like
40, this may be 60.
Celsius on the normal temperature.
Yeah, this may be 60. Yes, it's actually not allowed. 57. 7 degree Celsius. But this penetrant testing we can do from 16 to 52 degrees Celsius. Yeah, there is a minimum and a maximum. 16 to 52 degrees Celsius. If it is solvent removable chemicals we can use, because if there is a more temperature it will affect the viscosity, and if it is less temperature also it will affect cold temperature, it will affect the viscosity. Yeah, evaporated. So there is some limitations. Good sensitivity we will get from 16 to 52 degree Celsius. This is the solvent removable chemicals what we are using here. Yeah, on the surface. Yeah, we are talking the temperature about the surface where we are doing penetrant testing. Our test object. Suppose this is our test object, the temperature of this surface we are talking. This temperature should not exceed in between 10 to 52 degree Celsius. Surface temperature of the material 57. Yeah. No. 60 also we can use, but the problem is we are using the solvent. If you spray, it will evaporate or chance of smoke, because that is oil based. So if it is oil based means if there is a high temperature, it will smoke or it will evaporate. So there is no possibility is less. And of course we need some ventilations, because these are the forms we are using. We need the breathing problems or something. So wherever the area we are doing penetrant testing, there should be enough exhausting, enough air circulations and exhauster. Same environment. Then when not like a windy environment, we cannot do this. We cannot do spray like this. So the environment should be good. And of course, surface condition. Surface condition should be in a good conditions. So these are the some prerequisites to do the penetrant testing. These are the, we already explained regarding this one. Pre-cleaning. Surface to be examined must be free of any foreign material. Surface must be completely dry. Cleaning method depends upon test material, the surface condition and the foreign material on surface. So any material depends our situations or depends our job. We can select any cleaning method for the surface preparation.
Polymer and vinegar up to 10 mm
Not 10 mm, 10 minutes. Yes. That's, yeah, that is we are called not maximum, minimum. Minimum. That's what we are called dwell time. And if it is some manufacturer selling, if it is more time we are giving, suppose more than 20 minutes, maybe chance of dry. So we will do little bit again. We have to apply penetrant because don't give the chance to dry the penetrant. So up to 20 minutes is okay. More than if you are giving 40 minutes, so after 20 minutes, what we will do? We will do again reapply some penetrant to keep the wettability. So whatever the dwell time giving is minimum, not maximum. This is others. So the cleaning purpose also we told we can use any methods for cleaning. There is no any restrictions. Here we are using solvent. This is our method is a solvent removal method or solvent cleaner we are using. We can use either detergent, we can use vapor degreasing, steam cleaning, ultrasonic cleaning, scale remover, paint remover, acid alkaline HA, any of the method we can use for the surface preparation of the material. So in our practical, here we are using to do solvent. After surface preparation, we will give some time for the dry. The surface should be dry, and usually we are giving normal drying. Wait after cleaning everything, just wait 5 minutes to get the surface dry. We can use also, this also we can use, oven drying also we can use, but in normal site it's not possible after cleaning because we are using solvent cleaning means automatically it will evaporate. Within 5 minutes it will evaporate and our surface we will get a dry. Another thing, it's coming on the classification of penetrants. We have two types of penetrant. Like yesterday in magnetic particle also there was two types, one is fluorescent and one is visible. Say penetrant testing also we have type 1, type 2. Type 1 is fluorescent penetrant. We are using under the aid of the fluorescent lamp, UV lamp. The second one, type 2, is visible penetrant. That's what we have. Yeah, this is the visible penetrant. Because fluorescent penetrant we cannot see without fluorescent lamp. So there are two types of penetrants are coming. One is type 1 fluorescent and type 2 solvent visible penetrant. And there are some methods also. Based on the removing penetrant, the methods we decided based on the removal, how we are removing the penetrant from the surface. So the method A is water washable. Instead of this solvent, we can use water, but that's a different penetrant. So this penetrant material, it's written there, which penetrant is there, because on the top it is written that is solvent removable. So yeah, method C. So we have that is visible and solvent removable. Same we have water washable also. The water washable penetrants are coming, so no need of the solvent. We can use hose water and we can clean the penetrant. And another B and D is that's very rarely using, but it's a good sensitivity method is emulsification method. Emulsification, what we are doing is usually we are applying solvent penetrant. After the dwell time, there is one emulsifier coming, same like a chemical emulsifier. We apply a thin coat of emulsifier. So what's the use is, this solvent chemical become water washable. When you apply emulsifier, the solvent removable become water washable. So this water washable, this lipophilic and hydrophilic means on solvent. Some is solvent based and hydrophilic is water based. Lipo means solvent based. Solvent based emulsifier. Hydrophilic means water based emulsifier. So this emulsifier is only using to find out very minute or very critical cracks. So giving good sensitivity. This hydrophilic emulsifier giving good sensitivity in ultrasonic. So even minute minor hairline cracks also we can find out. But common practice we are not using. Commonly we are using either water washable or solvent removable. These two, method A or method C, we are commonly using. So this one is our method C. Type 2 method C. That is visible solvent removable penetrant method. So this is a method we are going to use. So the penetrant application, we already told we can use any method. We can do brushing, pouring, dipping, spraying, or any method we can use to apply the penetrant. Only thing is the penetrant should be equally cover or the surface of the material. Like this brushing. They are applying the penetrant with a small brush. We can use that one. This what is the dwell time. The length of the time the penetrant is to remain on the surface. That is we are calling it a dwell time. So usually it is specified in the procedure. Everywhere, wherever we are doing any NDT method, there will be one procedure. So this procedure is mentioned what time, how much time we have to given as a dwell time. If it is not mentioned, the manufacturer is saying this is 10 minutes dwell time. So either we will follow manufacturer recommendation or is our as per the procedure. If suppose if the procedure is saying 5 minutes, but we should follow manufacturer. Because some procedure may be saying we need only 5 minutes, but we are sorry, we cannot follow that procedure. In that case, we have to follow because manufacturer itself, those who made this one, he is saying minimum we require 10 minutes. So we cannot reduce that one. So in that case, we will follow only manufacturer instructions only. And do not allow penetrant to dry on the surface. Suppose if it is a drying, we will reapply the penetrant if it is appears to be drying. Suppose more than 20 minutes or 30 minutes, the time is giving, don't allow to dry, we will apply again the penetrant once more and keep it wet.
For reapplication, we have to clean first the first layer.
No.
On the same layer, we can apply.
Same layer, only light layer, only for to keep that wettability. Just we will apply there only. Yes, keep it wet.
Actually, we saw some application.
Yeah.
So they were using that technique. First they applied one coat, then give it a more than double time.
Yeah.
After that let it dry, then clean the surface,
Again,
and then again
again reapply.
and then give the double time, the normal double time. After that, apply the cleaning and then developer and read this.
Yes.
Actually, that was in SOP.
Yes. That
So is it against the procedure or
is we cannot say against the procedure, but because it's a reprocessing. Yeah, it's a reprocessing.
what condition we have to use this?
Because if we are confused or if this dwell time is not enough, sometimes, suppose if the dwell time is not enough, we can do this again because, yeah, we can do that. No problem. Yes. As to how to remove this excess penetrant. After the dwell time is finished, now this is a method C. We studied type 2 method C, visible solvent removable. Solvent removal method, after the dwell time, we can first wipe with a clean, dry, lint-free cloths. We are usually using the cotton cloths. Then wipe with a using some solvent and dampen on the solvent with the towel. Then again we will clean, and finally with dry cloths. Because after the cleaning, there will be no tracing on the penetrant on the towel. So the surface should be properly cleaned. That is means excess penetrant. We are saying it is an excess penetrant. We are not touching into whatever the penetrant goes in the defects. Only the surface penetrant we will clean until the final traceability is gone. So that is the cleaning method or removal of the excess surface penetrant. And the flushing of the surface with the cleaner is not permitted, because some technicians is very easy. What they are doing, they are not going to damp the cloth and clean one by one. They are directly spraying onto the surface of the material and clean. This is not possible. Yes, because if you are spraying means there is some pressure. So it may be chance to enter into that discontinuity, remove the penetrant there also. So that is not at all possible. But in practically, if you are going to site anywhere, you can see this, because there are a lot of jobs the technicians, okay, directly they are, maybe they are not aware about that sometimes, but some doing, but it's not at all allowed direct spraying the remover to the materials. This is the cleaning method, how it is cleaning. After finally, we will apply the developer. So after removal of the excess surface penetrant, a developer is applied in a thin uniform coating. So while we are doing the spraying, it should be thin coating and not too much, not too thick or not too thin. Depending on the type of developer to be used, drying the surface may be necessary. There are especially 4 types of developer is available. Now we have one developer, it is a non-aqueous developer. It's mentioned there. It's a solvent based developer. So like different types of penetrant, we have different types of developer also. So in this case, we are using non-aqueous. Non-aqueous means it is solvent mixed. There is some which is a dry powder also coming, some water soluble, some water suspendable, and non-aqueous. So whatever we are using is solvent based developer or non-aqueous developer we are using for our purpose. So just a classification of different developers are coming, like a dry powder, water soluble, water suspendable, non-aqueous type for fluorescent, non-aqueous type for visible and special applications. So in this case, our is a form E. We are using non-aqueous. Non-aqueous means solvent based. That is non-aqueous. So non-aqueous type 2. Type 2 means visible. First we said in the penetrant, we have a type 2, method C, and developer is form E. This is our combinations. We are using visible, solvent removable, non-aqueous developer. So this is our solvent based developer. This is the 3 bases we are using. This is a characteristics of the non-aqueous developer. the powder particles held in suspension in a volatile solvent. Test surface must be thoroughly dried before application. Application by spray, often in aerosol cans, like this is an aerosol can. Require thorough agitation prior to applications, and drying developer by normal air evaporations. So this is the characteristics of the non-aqueous developer. So usually this is spraying. The spraying also we should follow. Usually we are following some 10 to 12 inches distance only we are doing the spraying. Next is the development time. The time allowed between application of developer and viewing of indication. That is not much important like a dwell time, but the development time we will wait for the drying of the developer. As it is a non-aqueous developer, it will be immediately it will dry. When you apply the developer, it will be same second it will dry also. So that point onwards we can start our interpretation. So there is no need to wait for. So the time depends on type of developer, and the time should be specified in the procedure. Usually the procedure, most of the procedure saying 7 minutes developer, 10 minutes dwell time, and usually 7 minutes for the developer time. Normal procedure is saying that one. Development time, non-aqueous developer usually 10 to 16 minutes, aqueous developer 10 minutes to 2 hours, or dry powder 10 minutes to 4 hours after application. So different developer we can use on different timing for this purpose. This is just an example of this indication, because after removing, we have everything remove and apply the developer, and there is some leakage in the penetrant, leakage is coming. So that indicates some indications. There is some indications are there. Same like minor leakage field, it's showing pore, so maybe porosity. After that we will do terminology and types of indication, discontinuity classification, PT indication, which is rounded or linear acceptance criteria. That's the final our routine process we are doing for this evaluation purpose. Just some big manufacturers, different types of development systems they are using, tanks or something. Like if they are going to small materials, even minor too much pieces are there, they will prepare the penetrant in a big tank and putting all the material into the tank, and again they are processing. So the tanks also using for the like defense materials or minor part net. Yeah, same small nuts, bolts. So single pieces we cannot do penetrant testing. We cannot apply that penetrant on even minor pieces. So what they will do? They will put it in the tank. Yeah, at a time. Developer after that. Developer we cannot put it. Yes, this is separated. Another tank. So usually a kit means, or MBA PT kit means there should be one cleaner, penetrant, developer. For apply need some brush or something, some cloths like that. This is our penetrant kit. So if you are going to workshop or anywhere, one penetrant kit means minimum 3 chemicals. We need a remover, we need a penetrant, we need a developer. To apply that, we need some brush or something, cotton cloths, gloves, and that are the minimum things required in a. Yeah. Which one? Yeah, this is type 2. Yeah. Type 1 we need a fluorescent lamp. Yes. Type 1 the difference is same liquid. But that's yes. The same liquid, same bottle, but the liquid will be not a visible. That is a fluorescent penetrant, different penetrant. We have only type 2. Only type 2. Type 1 we don't have, I think you not purchased the fluorescent lamp. So if you want to test the type 1, we need the fluorescent. No, one not visible. Yeah, we cannot see. We can see with this light. This light. We need this light. And the area should be dark. Yeah. The white light intensity should not exceed 2 foot candles. That means almost dark area. We can use this fluorescent lamp. Then you can see the indication with a yellow-green fluorescent color. So that is the type 1 PT chemicals. So we don't have here in the type 1. If we want to type 1, we can purchase the type 1 penetrant with UV lamp, ultraviolet lamp. And the area should be dark. Such area we can use type 1. So we have only type 2 method C. Method C means solvent removable and form E penetrant, a developer, that is non-aqueous developer. These are the 3 chemicals we have. If you are using fluorescent lamp, this is a intensity meter to check how much intensity the light has. It is called a radiometer. So we can check, there is a 2 sensors coming. We can check the white light intensity and UV lamp intensity. Both we can measure with this one, with this radiometer. So these are the 3 items, PT materials we have. We need a pre-cleaner and post-cleaner. Mostly we are using the same one we are using. Visible and fluorescent penetrants, developers. So these are the 3 materials, 3 chemicals we required for the penetrant testing. Some other companies. The different companies, chemicals are coming now here using the spot check. Chemicals we are using, Magna Flax, so many companies manufacturing the, different company. No, this is some outside companies. Yeah, this is a Sport Check is a company. Saudi Arabia, I don't think they are manufacturing these chemicals. This is what 4 methods we already discussed. Water washable, post emulsifiable, solvent removable, post emulsifiable, method D also. So these are the 4 methods we are using. How we are deciding the method depends on the removing penetrant. That's what we are method. If it is a solvent removed by solvent, that is a solvent removable. If it is removed by water, that is water removable, or post emulsifications method. So these are the, but different chemicals, not the same chemical. So this is for, this penetrant is for the solvent removable. Same another chemical is coming for the water washable. That's different chemicals. And if it is a fluorescent, different chemicals coming. So that is mentioned there. Which is that one? It's already mentioned there, solvent removable red penetrant. That means a visible solvent removable penetrant. So each manufacturer they mentioned there, this is used for what method and what's our removable method. So, common errors occurring is, if the surface preparation is not adequate, if you are not cleaning the surface properly, there is a chance of error. Too many indications will come, different indications will come. Same insufficient dwell time. Suppose they are saying 10 minutes, we give only 2 minutes and remove the penetrant, maybe no chance of indication, because the penetrant did not get enough time to enter into the discontinuity. So, dwell time is important. And inadequate removal of surface penetrant. When dwell time is finished, we told we have to clean the surface, excess penetrant, no? If we are not removing completely, what will happen? When we apply penetrant, we can see everywhere red. We cannot find out which is the defect and which is not defect. So, the surface should be, after dwell time, the surface should be totally clean. Excess penetrant should be completely clean. If there is a little bit penetrant is still there, if we apply developer, the same penetrant will come out.
How to know this developer take all, absorb all?
No, that's why during cleaning process we will use white cloths. We cannot use a color cloths. Because if it is a red or brown color, we cannot find out. So mostly we are using white color cloths, and each and every wipe out we will check in the cloth. Any traceability is there or not. If you find still red or some traceability, again clean, until we are getting clean cloth. So finally we will find out, okay, this is okay. The surface is clean, excess penetrant is clean. Now what is remaining? The penetrant which is enter the defects. That's only remaining. So whatever the leakage after developer, that means that is an indication. Otherwise we cannot say from the surface or not.
Some penetrant inside the space.
Yeah.
How to know all coming out? You are cleaning only this developer.
No, if you put in the developer some 10 minutes, 20 or 15 minutes, the developer has the absorbing capacity. It will absorb all the chemicals. You wipe out again apply the developer. Again you clean the developer, again try to apply the developer again. If there is any penetrant is inside still, it will come out. Yeah, bleed out.
If you stay more time, can evaporate this penetrant?
Yes. So if it is more deep, if the defect is more deep, of course, maybe 2 times, 3 times you wipe out and apply developer, maybe still the indication will come. It will bleed out. And the developer is too thick or uneven, and contamination of PT chemicals. Sometimes that also, yesterday we talking about the expiry date. After expiry date, what will happen? So this contamination check also we will do on penetrant testing. There are different test pieces are coming for this contamination test. So we will check the contamination, what is the sensitivity and what is the quality of the penetrant we have. And ignoring non-standard temperature. What's the temperature we are talking about is 16 to 52 degree Celsius. So this is the temperature range which it can give a good sensitivity, 16 to 52 degree Celsius. So if it is below or more than that, maybe there is a chance of losing its sensitivity, because this chemical is manufactured to penetrant testing on that temperature, particular temperature. So that's penetrant testing. Yeah, we are called a liquid penetrant testing, but a short form we are. No, it's a common word, PT, penetrant testing. This is the process we are calling it's a PT, penetrant testing materials. LPT, yes. liquid pen, but common now industry standard they are using only the word PT. The like radiography they are using the word RT, magnetic particle testing using the word MT, ultrasonic UT, same penetrant test now we are using the word PT only. This is just a weld configuration. So any defects we can find out, but it should be open to surface. Yeah, surface cracks or surface porosities, anything open to surface we can find out with penetrant testing process. This is just a half welded stage. The root pass is over. So if there is any root cracks or something, usually in the high thickness job we are doing, this is very useful. Because suppose a 50 mm job, if you do welding final finish, final only we will find that, oh, root there is some defects. We have to do cut out all this 50 mm. So this penetrant test is very useful such a thickness job, because each and every layer we can do penetrant testing. Once they completed the root pass, we can do penetrant testing. If there is any defects, that time we can repair. We can solve the problem. Because otherwise 50 mm, wait for cooling. What we are doing, we do root pass and wait until cooling. After cooling, we will apply penetrant testing. And if it is okay, then only the welder go for the further process. Because otherwise, after 50 mm, you do welding, 1 day, 2 days welding. Finally, we will find that, oh, root, there is a minor problem. We have to do cutout. It's a loss of time, money, everything, manpower, everything. So to solve that problem, the penetrant testing, it is a very useful method. Even anybody can do. There is not too much technical skill is required. Anybody can do on each and every stage of the welding to find out if there is any defects or not. So that's a good method. Like this, incomplete fusion. This is not a completely welded. Some indications like this, fluorescent indications we are getting. This this is an indication from the fluorescent type 1 penetrant. See, very clear indications we are getting in the UV lamp, fluorescent lamp, the crack indications. So any material, any type of material, any configuration, we can apply the penetrant testing process. So these are the basic theory about the penetrant testing. It is not much complicated. It's a very simple process, and not much too much technical skill required. Not any area. The main advantage is any area, because a magnetic particle, if there is no electricity, we cannot use. But penetrant testing, we can use any area, any remote area, whether electricity is available or not. So that is the simple method, we can use that one. Like a visible cracks, open cracks, we can find out. This is a test piece we are using to compare the chemicals. Because yesterday we talked about the expiry date, no? So some materials after expiry or old stock, we don't know whether it is good or not. So it is like an aluminum block. So this aluminum block, what we are doing, there is 2 sections are there. One section we will apply new chemicals, what we purchased in new chemicals. And the other section we will apply old chemicals. And we will compare the indications, how the indication is coming.
Where is the old one? Where is the new?
Yeah. Here, this case, you see, the other side is more sensitive, the indications. Now, old will give you good indication. New. Old one, you will give a very fade indications.
Old one at the right.
Yeah, the right is the old one. So this is it is called a comparator block. This aluminum block is coming. So if there is any old or new materials, we will compare with this block and look the sensitivity, how it is. good or bad. Which one? This block we don't have. We did not purchase this blocks, aluminum block. But the other one we have. We will do the practicals. I have two. Two and one, you have already one pieces here. We can do that also. No problem. Same type of blocks. This is for the comparison of this old and new chemicals. Because this is actually two pieces, one piece and another piece. If it is showing all equal means that is good. Both the chemicals are good conditions. See, this side the indication is not clean. That means that chemical is contaminated. Whichever we shown the indication, that means that chemical is still okay. So like this blocks, so many types of block comparison blocks are there to compare the old and new chemicals. So many big companies, they have very old stock materials and maybe not expiry date finish, but maybe old stock. So when they purchase a new one, they can compare their chemicals with the old and new. Advantages of it is materials are relatively very compared to the other like magnetic yoke or ultrasonic machine. Comparatively, the cost of the machine, there is no machines, comparatively the material cost is very less. It's very sensitive, very versatile, commonly using everywhere. Almost any size, configuration and any orientation, anywhere we can do. There is no limitation like a yoke we can put here. Chemicals we can, if there is accessibility to spray, if there is accessibility to cleaning, anywhere we can apply the penetrant and very easy to use. So very simple method. What is the limitation is, first is time consuming. Because magnetic particle, there is no time consumption. If you put a yoke, immediately we will get the result. There is no need of any waiting. But this one, we have to wait dwell time. Minimum 10 minutes. Or before that, cleaning process 5 minutes, penetrant application 10 minutes, developer 7 minutes. So almost half an hour we have to wait to get one indications. So that is one of the major limitation is, that is time consuming. The second limitation is only those discontinuities open to the surface we can detect. Other defects, it's not possible. So, okay, let us start the demonstration. The same as we have some artificial defects. Test pieces are there. This is the low carbon steel. So as we told our procedure for PT testing, minimum we need 3 chemicals. So one we are using for the pre-cleaning, it's a cleaner, and another one we are using is the penetrant. So we are using solvent removable visible penetrant, and other chemical we are using is the developer. So now let us start the procedure. The first procedure, as we told, is the pre-cleaning of this surface. So what we are doing is we are just using our cleaner and cleaning the surface. Towards the camera. And clean it properly. So the surface should be free from any foreign material like oil, rust or any material, and it should be clean. Then just give the time to evaporate whatever the cleaning particles are there. Just let some time to evaporate the cleaner. And the next process is to apply the penetrant. So penetrant, we told we can use either spraying or dipping, or we can use a brush or any method. Here what we are going to, we are just using spraying method. We can do the spray. So when spraying, it's enough. Wherever now our area of interest is this belt only. So just try to cover the area of interest. No need to go for the further. Next step is the dwell time, what we told. So how much dwell time? Usually we give 10 minutes as per our manufacturer recommendation or as per the procedure. Just we are following the manufacturer recommendation, we have to give 10 minutes dwell time. So just wait for the 10 minutes.
It should be over.
Over. Okay. Okay. Now the next process is cleaning process. The cleaning process we told by step. First we will clean the excess penetrant with a lint-free cotton cloth. And we have to remove all the traceabilities.
The same plate which you were using yesterday?
Yes.
So give you two cracks. One
Yeah.
longitudinal.
And one.
So no need for this.
No, but,
But
you
still,
will see now.
still it is not visible.
You will see the red color.
We will
Dampen it, dampen it.
dab and the cloth with some solvent. And again clean. So direct spraying of this is not allowed because direct spraying may be chance to remove the penetrant from the defects also. So always dampen with the cloths and okay, almost. So no more traceabilities there. Okay. Now next stage is to apply the developer. So before developer we have to shake well. And usually the distance should be 10 to 12 inches away from the
10 to
yeah 1 feet, 1 foot away from the test sample. Just spray it normally.
Longitudinal is
No, no,
clear,
this
huh?
will take
Yeah,
Yeah,
it
it
will
will
appear, it will appear. Not so much. Yes. You see?
Don't touch.
No, don't touch, man.
هو معلوم yesterday معلوم yesterday
Recording. When you watch it again, if anybody is watching, they will hear
He
whatever.
will see.
This is. So we can put it.
clean this one back and clean other one
This
at a
one,
time.
now see, here
Yeah.
it is also coming.
Yeah, because this crack is very tight crack,
Right.
very tight crack. That's why the indication is coming very narrow line. So one line is very tight crack and one vertical crack is here. So it's not much deep. If it is more deep,
More deep,
the
more-
bleed out will be more.
More dye will come out.
Yeah, more dye will come out. The-
Show that crack.
You have to zoom and then you have the indication with the pen. It will slip, I think.
भारी है भाई. Done.
Okay, so let us go with the other sample. Same process. If anybody wants to do, you can do it. Okay.
instructions again,
Yeah.
so that it will be in the background.
Okay. So just clean it, and after that,
Only damp and it's
yeah,
not so.
and
Again, again.
yeah, clean again with the dampened cloths. So it will clean until the final traceability of this penetrant is will go on.
But the other one,
Better to change the cloth. Give me some spray. Cleaner. Just check here. I think
I think it's
Yeah,
okay.
close.
Yeah, close. So the next process is to apply the
नीचे की तरफ प्लेसेस है किधर बीड के साथ देख नहीं हमें नीचे भी चाहिए ना ये चीज़ चाहिए ये साफ होनी चाहिए थोड़ा दूर रखा थोड़ा दूर, हाँ।
And the penetrant bardo same distance
yes, penetrant
One
we have, yeah, no
No.
problem.
for penetrant.
Penetrant you can any distance.
Any distance.
Yeah, but this one because we have to get a uniform coating. That's why we will keep just away from that.
It's sufficient to split.
Yeah. it's sufficient. Let it dry. So, this is one leakage
Yeah.
we are getting from the edge.
You see this one?
This is more visible.
More visible.
Satish,
Satish.
next one is more visible.
This one.
So this is the edge of the weld. We can say it's an overlap or linear indication on the edge of the weld. It's very clear. And it is more deep also. That's why the bleed out is more.
That's the end of this.
Yeah. So whenever there is tight cracks or something, it depends. So from the bleed out, we can understand how much depth it is.
Any
Yeah.
severity you can
Yeah, severity. If it is more depth, then the bleed out will be more. And like this, the tight cracks, the bleed out will be
Now
very
crack
less.
here is more inside.
Yeah, more depth.
More.
More. That's why more penetrant will come out. So this is the basic method of solvent removable,
So,
visible
solvent
penetrant
removal.
method. So it's clear.
Yeah, it's clear. Thank
So
you.
okay, right out.